Hello everyone, welcome back to my channel. This is Tester's Toolkit and we will be doing a Java recap for QAs. I'm trying to make it very short episodes but in-depth episodes, and we're going to relate every single exercise we do to testing. So this is our tentative table of contents for now. We are going to change it maybe as we go along, but for our first 8 episodes, this is what we are looking at. This is episode 1, so we are going to be focusing on if statements. We're going to do single if else, multi-branch if, and nested if statements. Now, ideally, I wanted to code while on screen. However, the first recording was so long as I was coding and trying to speak at the same time that I decided to re-record it and just have the codes prepared. Generally, I don't like to do this, but we're going to do this for this episode until I figure out maybe a little bit of a different way. So for our episode 1, I want you to create a package by right-clicking on your SRC, create package. And I want you to name that package episode 1 if statements. You don't have to create a sub package. Now for first class, we have our single if statement. And what we want to do, we want to write a program that can identify if a number is positive, negative, or 0. If that number is 100, the outcome should be 100 is a positive number, true. 100 is a negative number, should be false, and 100 is 0 should also be false. So in order to start, we're going to create our integer variable called num, and let's assign the value of 100, which is what we're testing. And we're going to say if num is greater than 0, if num is greater than 0, we're going to say this is a positive number. Okay, now we are testing 3 parameters here, so let's do the other parameters as well. Now we're going to say if num is less than 0, we're going to print this as a negative number. And for our final parameter, we're going to say if num is equal to 0, we're going to say this number is 0. Okay. And each one of these if statements, as you could see where they begin and end, each one of these are single if statements. Ideally, as we go on, you're going to realize we would not in the future put single if statements like this because the time and complexity is too much. But for this example, we're going to leave it as this. So we're going to say num is 100. Our expected result is that num is a positive number. Okay, that is our expected result. So we tested the one parameter that we were given to test. Now there is something in testing called boundary value analysis, and I'm going to show you this because this is Tester's Toolkit. So we are going to test a little bit differently, to the normal QAs out there because we are testing at the highest level. I'm going to now test the boundaries by changing num to a double, and then we're going to say 100.1, and 100.1 is a positive number. Now, very simple. Let's put a negative in front of it. Our expected result should say that negative 100.1 is a negative number. Okay, great. Now let's do something here. Let us test 0. Okay, we're going to say this number is 0, but let's test 1 above the boundary, which would be 0.1. Okay, that's a positive number. Now let's make that negative 0.1. Okay, great. That is a negative number. Now let's do 0.5 negative. Okay, and now let's just do 0.5. It is under 1, but it is above 0. Okay, positive number. Great. So our program, we have tested all the boundaries, and our program is very robust. So we know for sure that this works. But these are single if statements. Okay, and if you notice about the if statements, it is not a capital letter. It is a common letter that marks the if. Now let's go back to our project and let's work on our if else. So for our if else, we're going to write a program that determines if a student pass or fail based on their grade. Now 50 and above is a pass, 50 and below is a fail. I went ahead and I wrote this program here, and I make grade a double because I'm going to show you why. So we said if grade is greater than or equal to 50, print pass, else print fail. Okay, because if it's not greater than or equal to 50, then it's less than 50. And if we put 100, okay, the student passed. Now let's try 50 because 50 is right on the boundary. And by the way, I love doing boundary value analysis simply because I love to just test to ensure that it is working. Let's try 51. 51 is right. It's 1 above the passing grade. Correct. Fine. This is the reason why I decided to do to make it a double. I want to test 50.1. So that is just 0.1 grade above the passing average. And as we could see, our program does function correctly. Now let's do another thing. Let's try our failing grades now. Let's do 49, which is 1 below the passing grade. Our expected outcome is that it says failed. Okay, let's do 49.9, which is 0.01 below the passing grade. Great, it did say that we failed. Now, I am going to show you something that is wrong about this program. Only because we're testers and I want to show you something. While this program is very robust, it does not take into consideration everything that it needs to take into consideration. Like, for example, the grade I put in is -3, and -3 is a fail. However, as testers, it's not just what you're told, it's also what you are not told. So while the question said, write a program to determine if a student passed or failed based on their grade, logic would dictate that if a student took an exam, or even if the student did not take the exam, they should not ever be awarded a negative grade. And our program does not take that into account. So -3 should have returned this is an invalid score. Likewise, if a student has 105, we know if this is a percentage system, the maximum percent should be 100. So again, what you are not told, if you have this and it comes, and you have your test cases, these are questions you're asking. What is our minimum? What is our maximum? What is our parameters? Because 105 passed. We don't know if 50 is a percent or 50 is just a numerical. So these are questions you have to ask, and I'm going to show you how to correct this in our next class. So I'm going to skip multi-branch if, and I'm going to go to our nested if, and I'm using the same question. Okay, write a program that prints a student's grade that takes a variable named score. If your score is equal to 95, your grade should be A. Now these are the parameters. Again, the question stopped here. Now as testers, this is what we have to think. These are the questions we're going to have to ask when you're in that Scrum meeting, that sprint planning. Okay, let's just assume that the given score is between 0 to 100. You're going to have to ask this. Well, what is the maximum? What is the minimum? What are the parameters we're testing? We can't just test infinity. We need to test within a certain boundary. Okay, 90 and above, what makes an A? 90 and above. What's the range for a B, C, D? And what range would there be a fail? So these are all questions that you're going to ask when you're in that Scrum meeting, when you are presented with what you need to test. Now that we've asked all the relevant questions, let's look at our code. What was given to us, it says it takes a variable named score. It did not tell us whether it's an integer or a double. And I'm going to show you. I particularly like to make it a double, especially when it comes to scores, because a score you could get 50.5 on a test. In terms of percentage, you could get those points, and those points could add up cumulatively. So I made it a double. If you make it an integer, you also could be doing yourself a little disservice when it comes to testing the boundaries, especially if you're doing, for a college. I did a project for a college, and making it a double return more accurate information to the students. So now we're going to say, remember we spoke about the parameters. Now, this is what takes the parameters into consideration. We are going to say what scores are valid. So we're going to say if score is greater than and equal to 0 and score is less than and equal to 100. Okay? If the scores are within this range, then these are the condition. If it's not within that range, I want you to print invalid score. Please enter a score between 0 to 100. Okay? I hope you understand that. I hope you see that here, how the code is written. So this is our first if statement, and this is our outer else statement. Now, this is inside our if statement. We have another if statement, and this is called a nested if statement. Now, our nested if statement says if score is greater than and equal to 90, your score is an A. If it's greater than 80, it's a B. Now, why did I put that? I'm going to show you when we're testing. If it's greater than 70, it's a C. If it's greater than 60, it's a D. Else, fail. We don't need to say if it's less than and equal to 59, fail. We already have a condition, and that is why I put these conditions here. Because if a student scores, say 72, right? 72 is not greater than or equal to 80, which means that it's going to be picked up by this other else if statement. Sometimes when you're a new tester, you're a new coder, you tend to say, well, I need to say it as how it is written here. 70 to 79. You actually don't need to, because 90 and above is going to take care. This first if statement is going to take care of everything 90 and above. The second if statement is going to take care of everything 80 up to 90, because we already have an if statement that takes care of 90. Same thing. This third if statement greater than or equal to 70 is going to cut off at 79.9, where then this else if statement is going to take over. I hope that makes sense. So you could write your code very effectively and make it look very nice and clean. Now let's test this. Let's say our students score 50. What is our expected result? And again, when you're running tests in your mind, you should already have an idea of, okay, this is what I'm expecting it to return. Let's see what it returns. Failed. Okay, we know because we said below 60 is a fail. Let's say the student got a negative 56 on the test. Should that be allowed? And as you can see, IntelliJ is so smart. It already highlighted which if block is going to be executed. And again, we all know if you're writing a test, you can't have negative 56. See, invalid score, please enter score between 0 to 100. I should say, please enter a score between. Okay. Now, let's test all of our boundaries, because again, this is a QA recap. What are our boundaries? We need to test 59.9. We need to test 60. And we also need to test 61. So let's do that. So 59.9. Because when you're testing, remember we said you test the boundaries. 59.9 is a fail, as it should be, according to our program. 59 is also a fail. Now, let's test 60. Your score is a D. Great, let's test 70. Your score is a C. Let's test 80. And I'm not going to test all the boundaries here, but I am going to tell you, you need to test 80, 81, 79, 79.9, 80.9. Then you need to test 89.9. I'll show you why. 89.9 should not return us a value of A. It should still return us a value of B, because according to our program, B starts from 90. Let's do something here. Let's try 99.9. Your score is A. Now let's try 109. 109 should not give us a score of A. 109 should bring back invalid score. I really hope this is a thorough explanation of testing the boundaries, and I am going to put in the code. I'm going to put in some extra notes of everything that we need to test. We need to test 79.9. We need to test 80.1. We need to test 89.9. And then we also need to test these values here in negative. Okay? We're going to test every one of these boundaries for all of our codes. Additionally, in order to do the validation code, we're going to test 0.1, and this is not something that we test, right? We did not test 0.1. What if someone only scores 0.1 because they only wrote their name for the test? And let's hypothetically say for just showing up, you get a score of 0.1. Great, it said failed, because 0.1 is just one above the boundary. So if someone just showed up to write their name and they're awarded a show of 0.1, they should have something that says that they failed. I really hope this explanation is great. We're going to go into very detailed testing the boundaries. Again, boundary value analysis. I really like to do it. I feel like majority of the mistakes are made around the boundaries anyway. So that is why we test. Now for our final topic, we're going to go to do nested if. I don't want to make this video too long. We're going to revisit the same program that we did for the first if statement, a single if statement, and the program that says write a program that verifies if a number is positive, negative, or 0, and I'll show you that as a multi-branch if statement. Now we have an integer num of 100, and again, remember, we would change that to double, because we are testers. We're learning from the best, so we're testers. This is how we do it. We try to test every possible scenario. And again, as testers, we're not testing to verify the developer's code. We're testing to break the code. Once things are in production, multiple scenarios. So we do have to think of all the scenarios in order to create robust and amazing programs. So this is a multi-branch if statement. You're going to have the double for the num, and you're going to have a result. It is the same single if statements that we saw before, except we're going to have to print out whatever the result is, and the result is an empty string. This, whatever is in that print statement. It's called a multi-branch if statements because it's multiple if statements that is connected by one print statement. See, 100 is a positive number. If we put 101, and again, we're going to go through the same thing that we went through in the single if statements, where we're going to test the boundaries and in between and everything to ensure. So this is just a quick recap of multi-branch if statements, single if, nested if, and if else. In our next episode, we're going to get right into switch and ternary. So stay tuned for episode 2. And again, have a great day. And thank you for subscribing to me, and drop me a comment if you have any questions.